kind of kick off today and talk about data center architecture and cloud computing storage trends. And I'll kind of break this down into three levels. One is we'll take a look first at the industry layer of progression of cloud computing and the catalyst behind that. And then we'll drill down a little bit further into the data center, but more at the macro layer, looking at the data center architecture from that perspective. And then we'll actually drill down into some racks and go through some case studies of where we've been deployed into hyperscale environments today. So the first step is to kind of take a look at the industry view of how we progress IT as a platform through time in this industry. So we kind of started off with the mainframe era. We didn't really have very much connectivity out to users. We just had this terminal interface. We really didn't have very many applications, but for the day, it was a very exciting machine. It actually put humankind on the moon. It really progressed us out of the industrial age into the information age. But what we've noticed now is roughly about every 20 years, multiple new technologies intercept and come together and define a new IT platform that is consumed by the users. So roughly in the mid-70s, right, we had the PC that entered the industry, but that wasn't the only thing that actually came in. There was new operating systems with Unix, Linux, and Windows. There was networking technology. There was a new microprocessor from Intel. There was actually also a new data flow model that was brought into the industry via Oracle, the relational-based technologies. But a clear pattern does emerge where when a new high-volume client device enters, what comes with it is a lot more new consumers of this new IT platform, and as well as lots of new applications. So here we are today in this kind of third platform era of what we call in the industry cloud computing. And again, the pattern of a new high volume client device, cell phones, mobile, tablets are proliferating our world. And what we're now doing is connecting those devices into cloud computing data centers or information factories that we can deploy applications and services at scale. And I kind of use the analogy here of dark energy, which in the real universe is something that is causing it to expand very, very rapidly, but we don't actually know what dark energy is. And over here in IT, we have this thing now called big data. And we figured out how to do some interesting things with big data, search technology, some big data analytics. But I think we're really on the very beginning stage in terms of the impact of what big data will bring to this third platform era. And what we see along the path is the universe of available market actually goes up at least 2 to 3 times over platform generation. Now today, this second platform era is basically flat or declining in terms of growth, and all the high-tech industry, would really not be investing in this area, right? So what's going to be driving our architectures and driving our decisions is this type of growth up here in the third platform. So back a little bit to the big data. What's a little bit different this time in this new digital universe is that we not only just have one new client device that's driving this type of data growth and new users and new applications. It's actually looking at some Cisco projections, with with the Internet of Things being connected, it's 50 billion type devices, everything from wearable computing, smart automobiles, smart homes, smart grids, smart transportation systems, livestock being Internet connected for health monitoring purposes, hospitals. In fact, IBM actually has a projection of 1 trillion Internet-connected devices in 2020. So what this does is actually it accelerates the growth in this third platform era much faster when we specifically look at the data piece of that platform architecture. And what's interesting is where we end up in 2020 when we start talking about storage is we're projecting 40 zettabytes of stored data by 2020. And to give you an idea of what the impact to the infrastructure that would be, and Neil will show you some very high density solutions that roughly about 2 petabytes per rack. You're looking at roughly about 500,000 racks to store 1 zettabyte of data. So a tremendous challenge in front of us when we start looking about this new digital universe. The other is to dig a little bit deeper into exactly, what is the impact of big data? Why is it a challenge? And when we just look at it from a volume perspective, it's actually really not a challenge. The biggest volume of this type of data today is video. It's really not hard to process and distribute video. What gets hard is when we look at the variety of the different types of data, all of this unstructured information that we want to go in and look for signals in order to gain competitive advantages and grab value out of all of that variety. And then when we add in velocity into the equation as well, in terms of being able to process this, or even being able to acquire this data at very high rates, as well as process it at very high rates, this becomes a very big challenge, especially at volume. So we want to also look at these two other areas, variety and velocity, not just the volume. And here's a project that's already being constructed what we call the square kilometer array. And their intent is to acquire 750 terabytes per second of data, process over 1 million nodes, 1 exabyte per day, and then physically store 1 petabyte per day. So this is an idea of what we're going to be faced with in terms of data center architecture, in terms of being able to provide scalability into the future. And the irony of this particular application is its intent is to actually try to figure out what dark energy is and why the universe is in fact expanding. PMC is investing across all 3 of these areas very aggressively. You saw Greg's slides about our growth in terms of revenue in the storage space. And here's a big look at our portfolio. And one of the advantages that we have is the breadth of the portfolio and our ability to address very high density applications for volume, the ability to also do integrated security processing for high performance. And also what's new to the portfolio is last week we announced the intent to acquire IDT's PCIe flash controller business as well as their PCIe switching, which really gives us, along with our own investment in 12 gig SAS controllers, a very broad portfolio for this velocity part of big data processing in order to address very high speed applications. And we'll show you some use cases of where we see flash being used today within the data center. From a perspective of market leadership, we are actually the market leader in terms of SAS port connectivity over our competitors in the market. And a big reason for that is that we have a very broad set of suppliers and partners on the on the array side, NetApp, EMC, IBM, HP, Huawei, and of course we have Dell DCS here today from the perspective of being able to deploy solutions with us in hyperscale data centers. And then as we look, where we deployed in terms of applications within the data center today, here's an example using some industry standard taxonomy of the infrastructure as a service, platform as a service. This is how we kind of define what types of services particular cloud data centers offer. We're in three of the top three multi-tenant virtualization deployments in the world. The top three storage as a service. We've done content delivery network applications. And then the top three platform as a service data centers in the world use PMC technology. And then up in the software as a service type data centers, we have the world's largest search engine running on PMC technology, gaming as a service, large social media type data centers. And then we also have multiple enterprise services deployed, such as data warehouse, Hadoop as a service, Oracle as a service, and then some various e-commerce sites use PMC and Adaptec technology. And what we'll do is take a look at a couple of these use cases when we go through the case studies. So where have we been in terms of building data center architectures? In the past, what we did is we had silos of infrastructure that were vertically integrated and vertically optimized in order to run pieces of our infrastructure. We had the web tier, we had the application tier, we had the database tier with a large connected storage area network. I actually worked at Sun Microsystems, and we built very high-end servers to run Oracle better than anybody else in the world. And the way we did that is we went all the way down into the microprocessors, optimized instruction sets for Oracle. We optimized the Solaris operating system, the whole memory architecture, the whole I/O architecture in order to run that one particular workload better than anybody else. But the problem was that it wasn't scalable horizontally. It was way too expensive. The same thing is actually was happening on the network side. We wanted to take our web tier and pound on this particular chunk of data. We had to go up through the Cisco 3-tier architecture all the way to the core and back down to the SAN in order to do read-write of that data. And this is what we call north-south traffic patterns, and that would work very well in a vertically architected environment. But what happened was a couple of new workloads came along, one being virtualization. And this really changed everything in terms of data center architecture, because all of these various physical layers, security layer, the switching layers, the storage layers, all collapsed down into the server, into this hypervisor layer. So this became the new edge in terms of interfaces to our infrastructure, and this was a software layer, and the advantages of that was a lot of flexibility, but the downside is it was a performance impact. So in one of the case studies, we'll take a look at how to basically improve the performance of that from a storage perspective. And then the other application is really the big data application, where we have this massive amount of data that is no longer we can no longer go process it efficiently if we put it on a SAN in a single centralized location. The better way to do it is to break it apart and distribute that data across many, many nodes over a highly scalable cluster, okay? And what this did in terms of data center architecture is it defined this new category, what the industry analysts now call the CompuStore, which is really the convergence of the data with the compute. in order to horizontally scale out. In both of these situations, what they did in terms of workload is they both generate a lot of east-west traffic. So the first step now as we move inside the data center and take a look at the data center architecture is the first thing that we want to build out is a fabric that's very flat, of course very fast, very low latency, that has full cross-sectional bandwidth between every piece of switching fabric between here. And then what we also need to do is expose this fabric out to a broader data center of data center connectivity, because we may have disaster recovery needs, we may have geographic specific services that we're deploying in different parts of the country or the world. We also may have content delivery and caching oriented data centers serving a much larger facility where we do processing. PMC has a technology that we've deployed in data centers today, our OTN technology that is used for this for very high speed connectivity between data centers. But as we move back down into the rack, what we've now started to do is cut down on the number of SKUs and configurations of servers that we put into the racks, with a strong emphasis on very high density on either compute and or storage. In order to run either one of these workloads, virtual machine workloads or big data workloads. So this infrastructure needs to be able to hit some key requirements in terms of very high architecture density, like what Dell VCS is showing in terms of the demo back here, and Bingo will walk through some just awesome designs in terms of architecture density. But we also need to be able to run multiple types of applications. So that means that technology, say from PMC, needs to be able to address many different workload patterns. So we need to address low latency performance, high throughput, and then obviously in order to scale, we need to be very low power and space efficient. And since the slowest speed technology in the data center is this rotating hard drive, we need to pay very close attention to latency on a per node basis. Because the minute we inject latency into this fabric, we run tremendous risk of outages, poor application performance, we'll lose customers. So we'll talk about the importance of maintaining a low latency scale out architecture. And a big part of that is starting to use solid state disk within our server nodes and data nodes. There's an increasing gap between our volume hard drive technology and our new velocity technology, which is flash. And it's just amazing the difference if we look at the IOP transactional performance, close to 2000x improvement over a rotating hard drive. And by the way, 15K hard drive is the fastest hard drive. A lot of SATA drives are 7200 RPM. So the other is latency. You can see a 100x improvement when we use PCIe SSDs, and of course a bandwidth improvement. And this is a big reason why we made the investment that we did in our intent to acquire IDT's NVMe PCIe flash technology. This brings us much closer to the CPU, going native PCIe versus going through the SAS protocols and the OS overheads related to that particular technology. So this is a key technology in enabling us to manage our storage across a scaled out environment. Very flexible, in a balanced way in order to keep that latency down throughout the entire data center to, again, enable us to scale out. So now we'll kind of move and take a look at some of these case studies that we've been deployed in today. And the first one is this kind of CompuStore-based environment where what we want, and here is actually a Hadoop data node example. And here what we want is a very rich balance between compute power and storage capacity. So we see a strong demand using, say, standard 2U servers with 24 drive configurations. And historically, what you would have to do is use an 8-port card and fan that out with using a SAS expander. And the problem with the SAS expander is it injects on a per node basis power, cost, and latency impacts. And what we did is we came along with this Series 7 24-port adapter that's direct attached 24 drives, so no need for an expander, that's much lower power, lower cost. And when we look at the impact at scale in terms of efficiency, just looking either within one rack or over 5,000 racks, the impact on power and capital equipment investment it gets very dramatic in terms of savings when we start looking at 5,000 racks, for example. And by the way, I don't really know any hyperscale data centers that have just 5,000 racks. I mean, most people are more in the 10 to 20 to 100,000 range. So it can really get dramatic in terms of the savings when we look at the scalability impact. The next case study is the multi-tenant virtualization environment. And here is an architecture practice that we see being used over and over again is the use of hybrid storage pools. And this is where our friend, the hypervisor, comes in that injects a lot of performance overheads and latency. And what we need to do is remove that. And part of the challenge is that each virtual machine can be, a completely different application. It could be a completely different operating system. Some of these virtual machines could be doing reads or writes, different block sizes. So what we want to be able to do is cache that hot data into a pool of SSDs on either reads or writes, and then the cold data push off to the capacity tier using slower rotating media. So this is pretty much the #1 use case for solid state disk in the market, is to clean up this particular performance issue. And one of the reasons why we're investing in our own flash controller technology is because we believe we have an advantage in terms of being able to offer SSD products through partners or through Adaptec that are much higher capacity than what we see on the market today, as well as much higher IOP performance. A typical Intel SATA SSD today is less than 1 terabyte and roughly 70 to 90,000 IOPS, and we could basically, do that 3 to 4x. So we could we're looking to enable the market to basically acquire fewer SSDs at much higher performance to really lower the cost of this technology. And again, the impact to latency is many times, it's measured in outages most of the time. Here's a feedback from Amazon that pretty much, every 100 milliseconds of latency costs them 1% of sales. And of course, Amazon, through their website shopping, drives, billions of dollars per day in revenue. So it's a huge impact that has to be managed very efficiently, and we see that SSD is really the technology to drive that problem solution forward. Now, there's several PCIe architectures on the market. A lot of the early leaders came out with FPGAs, And now, of course, PMC has very highly scalable ASIC technology. What we've done in terms of an analysis is we look at the NAND technology and the problem of managing NAND over time as the technology progresses into smaller node counts, into 20 nanometer and beyond, that the overhead or the processing power required to run all the error correction in order to have data that's not going to get corrupted and destroyed, where you would be looking at using roughly about 80% of a Vertex 7, and that's a $1,500 chip. So it's just not a scalable path to use NAND with FPGAs. It's just going to be way too much power and way too much cost in order to try to basically maintain any kind of endurance level of capability. So again, this is why we spent the time and energy to invest in an ASIC direction, and we really feel that we have at least a 1-year head start, especially now on the progression with PCIe and NVMe. The third case study is taking a look at, say, storage as a service. And many people that we've seen here use OpenStack technology, which is an open source initiative started in the US, but it's obviously now all over the world. And here we see a configuration of a scalable head node where the metadata and the journaling and the caching are done inside of this server here with a certain amount of SSD, so roughly about 8 drives here. Then we want to connect externally into a big pool of object storage, and people fan out into JBODs. And the challenge that we see is, and that we're addressing, is that typically you would need 3 different HBAs in order to get that kind of density and solution achieved. So we came out with a product that is back here, and you'll see this show up in Bingo's presentation and several solutions as well, called Super D. And it's 8 ports of internal connectivity for that SSD type environment, and then 16 ports of external connectivity into a series of JBODs. And we see multiple use cases for this, not just storage as a service. We see cold storage where we could actually run 16 JBODs. I think actually Bingo will talk about that as an application as well. So again, back to the theme in terms of being able to provide highly scalable technology to really drive efficiency forward in terms of cost and power efficiency. Another piece of what we've done with our overall portfolio, but we also see this deployed in the case of OpenStack environments, is to be able to manage our low-layer technology. I think Don will also get into this as well, to where we can, through programmable APIs or CLI interfaces from higher level management infrastructure like OpenStack, be able to control our device level technology in an automated way to either do workload optimization or even automated management. So here's some features that we have in order to be able to tune our device to run different types of workloads in the data center, whether it be optimizations for Oracle or SQL Server. And then another feature that we've added specifically kind of for this variety-oriented processing big data problem, where we see a lot in hyperscale data centers, where there's a lot of large blocks, especially say in an object store, Hadoop clusters, and we don't want that to go in and trash our cache, but we want to bypass that directly out to storage, give it higher priority, and then let the smaller blocks take advantage of the caching technique within our controller. So kind of, in summary, PMC is clearly a leader in hyperscale from a storage perspective, and we showed also we have some of our communication technology that's also deployed in these environments for data center to data center connectivity. But one of the things that we're very, very focused on is, again, this efficiency, power savings, consolidation, and CapEx savings. Being around this particular space for 7 years, that's a consistent theme that everybody struggles with as we add that next 5,000 racks or 10,000 racks to be able to control the power and cost. And again, in terms of the best practice, we really see the deployment of this CompuStore environment, this consolidation of compute and storage to cut down on the number of SKUs. And again, I think you'll see a very strong message and capability there from Dell ECS. Natively attach in order to get rid of latency without cost, drive up the IOPS. Again, the best mechanism to do that is some kind of balance with using solid-state disk technology. And then being able to do workload optimization and tying that in a programmatic way into higher level automation tools within the data center. So big challenges as we kind of looked at this new dark energy of big data, but also big opportunities for the industry, and we really look forward to partnering with you as we go forward. Thank you very much.